Hello everyone, welcome to the third lab session of DSP lab. So in this lab, we will be learning about how to compute pulse rate for the PPG signal and pitch speed of a signal using autocorrelation function in real time. So what is an autocorrelation function? Autocorrelation function is the process of relating a signal with its delayed signal, and autocorrelation function is also known as serial correlation. So what we do in autocorrelation is we relate a signal with its delay signal and find the properties of the autocorrelation function. And in autocorrelation function, if we see the maximum value of an autocorrelation will be the zeroth value of the autocorrelation function. So coming to the pitch period. So what is a pitch period? Pitch period is the time required for one glottal cycle. And what is a pitch frequency? The inverse of a pitch period is a pitch frequency. So for speech signal, so in this experiment, we assume the sample rate of 8100 Hz and resolution of 10 bit and frame duration of 5 seconds to compute the pulse rate from a PPG signal. So first, we compute autocorrelation function for each frame with a specific frame duration by using this expression. And in the expression, we can see that we are normalizing the signal by dividing the by each and every term with r of 0, that is the maximum value of the autocorrelation function. So how do you find the pitch period of the pulse signal? So we will be taking the pulse signal and PPA signal and we compute the location of the first zero crossing point of the autocorrelation function sequence of the PPA signal. So after computing the first zero crossing point, we take a window from first zero point to infinity. This will be the next window, and in this window we will compute the maximum value of the window and also obtain the maximum value location, that is L max. So after computing the maximum amplitude location, we apply that we find the first zero point location plus L max and we divide it by the sample frequency, and this will be the pitch period of the PPE signal. By inverting the pitch pair, uh, we can find the pitch frequency. So going to the code part, here we can observe that we are taking 2000 samples of the PPE signal, and so we can observe that whenever you take a PPE signal, as I said in the last lab session, we can observe noise in each and every signal we take. So first we need to do the filtering of the noise. So we apply moving average filter to the signal and obtain the pure signal from the obtain a noise removed signal from the PPA signal. So here you can observe that we are applying a moving average filter to the signal and obtaining a moving obtaining the noise removing the noise. So after that, we need to remove the mean from the mean from the moving average filter signal of the PPE signal. So here you can observe that we are finding the mean of the moving average filter signal, and then we are removing the mean from each and every term, each and every point of the PPE signal. So coming to the next, we should apply the autocorrelation function. Coming to the autocorrelation function, this is the autocorrelation function that we are going to apply right now. See, we have find the r of 0, that is the maximum of the autocorrelation function, and then we have applied that y of I into y of we have applied the following this expression in this. So we have applied this expression in the Arduino board and found the autocorrelation function. So this is the autocorrelation function, and then we found the L max and the maximum values. We we applied the so we can observe that the pulse rate is given as the number of beats the heart beats per minute. So we will be doing 60 into 100 by 60 into fs by L max. So it will be 6000 into 6000 by L max. So after finding after so first let's compile it. So autocorrelation function doesn't autocorrelation function doesn't require more about the noise also. The best part of the autocorrelation function is if you remove the moving array filter part also, you'll get the same thing. That's the best part of the move. So I uploaded the code and we'll find the see this is the autocorrelated and normalized signal of the PPA signal. So you also found the heartbeat of the signal. So let's find the value of the heartbeat of the signal. So it's uploading. So you can find the values of the signal. You see, these are the pulse rate of the signals. So we found the pulse rate of the signals. And thank you. And let's meet in the next session.